Okay, the first thing I'm going to do is I'm going to graph. I look at this and I say, y is squared, x is. This is a parabola. I could rewrite it in this form. And I say to myself, that means that my vertex is at 0, negative 5. 0, 1, 2, 3, 4, 5. My LLR is right here. That means it's going to be 8 wide. But first I'm going to go down 2 and up 2. Because x is squared, it's positive, right? Everything's positive, so it's going to look like this. That being said, that means my directrix is right here. And it's 8 wide, so I'm going to go out from my focus. 1, 2, 3, 4. And 1, 2, 3, 4. There's that. This one, neither one of them are squared, so it's a line. And I'm going to start at negative 5. Yep. So I'm actually just found my first intersection point. And then I'm going to go up 1 and over 2, up 1 over 2, up 1 over 2. There's another intersection point. So that would be at 0, negative 5, and 1, 2, 3, 4, negative 3. Now I'm going to do the math to check it. All right, so this whole thing right here, let's see. All right. Let's pretend that y equals a heart. Okay? If y equals a heart, couldn't I put a heart right there for y? Right? Okay, well, y doesn't equal a heart, though. Y equals that. So we're going to put that right there, where the heart is. Okay? Does everybody agree? Does that help a little bit? I think you guys are having a hard time with the whole idea of substituting something more than just, you guys can substitute if I said that, right? Then you're fine. You're like, oh, I'll just put a 2 there. But as soon as I put something big like this, you guys like freak out. But it's the same thing, right? Okay. All right, so I'm going to substitute in. So I have 8, parentheses. There used to be a y there. Now it's going to be 1/2 x minus 5. Then I'm adding 5 to my y, which this is my new y right here, equals x squared. These cancel each other out. So I'm left with 8 times half of an x is 4x equals x squared. Then I'm going to make a giant error, big boo-boo, and then divide by x. So 4 equals x. What happened? You can't divide by x. Why? Why can't I divide by x? 4 equals x squared, right? So right now, I only have one of my solutions, right? X equals 4. I lost the 0. Well, the reason that you don't divide by a variable is because sometimes it is 0, which it is. And if I divide by 0, and oh, we don't do that, right? It becomes undefined, right? All right. So I don't want to do that. Don't want to divide. So I'm going to move that 4x to the other side, so I get 0. Now I can factor it, or I could complete the square. Okay? I'm going to factor because it's easier. Now I have two answers. I have x equals 0 and x equals 4. Now it matches. So now all I have to do is find my y's by plugging it back in or substituting it back in. I'm going to put that over here. I'm going to put two of them. I've got y equals 1/2 of whatever x is minus 5, and y equals 1/2 of whatever x is minus 5. I have two solutions to put in there, right? When x equals 0 and when x equals 4. And if I plug that in, I will get -3, and if I plug that in, I'm going to get -5. That part, I think, is not a big deal to you guys. It's how you started. Correct? You guys ready to do another one? Okay. Go ahead and do that one. There's some right here in this basket. Where's the basket go? The pencil basket. Uh-oh. I never paused it. 1. Okay, so this one a little bit faster. First I'm going to graph my parabola. I know that it's orientated on y, and this is both positive, so I know it's going to look like this. And my vertex is going to be at 0. Sorry, not 0. X is 1. Y is 0. So 1, 0 right here. My LR is 4, so I'm going to go out 1 and out 1. Since it's positive, this is my directrix. Out 2 to make a total of 4 wide. Then my line is 2x minus 2. I'm going to go down 2, then up 2 over 1. There's an intersection right there. Up 2 over 1. There's an intersection right there. So I have two solutions. One is at 1, 0, and the other one is at 2, 2. Let's double check. So I'm going to say 4, x minus 1 equals whatever y is squared. Y just happens to be 2x minus 2. So I'm going to go ahead and distribute my 4, so 4x minus 4 equals 2x minus 2 times itself. Negative 2 times 2x is negative 4x, and negative 4x makes a total of negative 8x. 2x times 2x is 4x squared, and negative 2 times negative 2 is positive 4. I'm going to pause there. And do we have questions about that? All right. Now what do I need to do? Ooh, I like that idea even better. Normally I'd subtract 4x and add 4, but Allison noticed that, hi Christian! Allison noticed that everybody has 4 in common. I could divide everybody by 4. Good job, Allison. Very impressed. Divide by 4. 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 It made our problem a lot easier, didn't it? Okay, so now it's x minus 1 equals x squared minus 2x plus 1. What would you guys do now? You've got a quadratic right here, right? We've got to solve. The only way to solve with a quadratic, there's 4 different ways. There's graphing, which isn't going to work for us right now, right? There's what? Complete the square, quadratic formula, and factoring. Okay? Okay. So then you would complete the square. But this one isn't really a good one to complete the square with, is it? So if I add 1 to both sides, I said I was going to go fast, and now I'm not. Add 1. Subtract x. Subtract x. Add 1. Now I have 0 equals x squared minus 3x plus 2. Is it factorable? Yes, it is. X and x, 2 and 1, if both of them are negative, they're going to add up. Negative 2x and negative x makes negative 3x, and negative 2 times negative 1 is positive 2. So my two x's are x equals 2 and x equals 1. Does that match? 2 and 1. I don't think I need to go any further, right? Now you plug those back into the original. I'm just going to write it out. Our original is right there. Y. Oops. Y equals 2, whatever x is, minus 2, and y equals 2 times whatever x is, minus 2. Here, x equals 1. Here, x equals 2. Questions? Do we need one more? Yeah? Okay. You guys do that one. I'm going to walk around. So I'm going to go ahead and work this one out without talking. 1, 2, 3. Oops. All right, so let's talk a little bit about what's coming up. So your homework tonight is review packet 12 through 24. Okay. Tomorrow is the last day to email project to me to print. Project is due not Friday, Monday. This didn't save on me. I'm sorry. Wednesday. What else is due Wednesday? Review packet. What else? Cumulative. Okay? All right, your question Friday, sorry guys, Wednesday's final is 5 questions. Okay? One of them looks just like what you did today. All right? That's why we were looking over it. So 5 questions. So they're going to be kind of long questions, right? They took me 10 minutes. It took me 10 minutes to do it. Right? Who said they're not going to be here on Wednesday? Okay. So that's Wednesday. That's the short answer portion of the final. Then there's 24 multiple choice. We're going to do that on Thursday. Then Friday is going to be a group task, or possibly, I might not make a group. I might make it a task and make it part of your final. Okay. All right. Let's look at absolute value functions. Oh, first let's do that matching that's on there. Can you guys, did you guys match it on the back? Let me give you 1 minute to match them on the back. Okay. So this one is obviously a parabola, right? It's got y being squared, so I know it's a sideways parabola, so it has to be that one. Okay, this one looks like it, does it have, I can't read it. Does it have a plus sign or a minus sign? Oh, so it must be a hyperbola. All right, which hyperbola is it? It's the top one because y comes first. This one is also a parabola, but x is being squared, and it's negative, so it's going down. I need another color. This one is a plus sign, so it's either a circle or an ellipse. Because it's the different coefficients, it's an ellipse. Oh, wait. This one's also a hyperbola, right? Because it's minus. But it's starting with an x, so it's... Okay? Easy? Easy peasy? Okay. All right, I'll just choose semester 1, types of graphs. We did absolute value graphs in the very beginning. Then we moved to parabolas, circle, ellipse, hyperbola. Fun stuff. Okay, so we're going to do one really, really quick review, for like 3 minutes. Then you're going to do one problem, and then we're going to check our answers. You need to work on your packet when you're done, or your cumulative, whichever one you want. All right, after you do the one single problem. But let me do one for you first. Okay? Okay. Ready? All right, pencils down, eyes up here. So if you remember, way back in the beginning of time, right? I need everybody's eyes up here. Everybody up here. To solve this graphically, we split it up into 2 different equations. We said the one in the blue is f of x, negative 1/2, x plus 1 minus 3. And we said the other one would be g of x. Remember that? G of x equals negative 5. Well, that one's easy. Right? 1, 2, 3, 4, 5. There's negative 5. But this one, we had to do something to it first, right? We made it a y. And then we put it in transformational form by adding the 3 to the other side. Equals, should have had an equals in there, equals negative 1/2 x plus 1. So we have, this is just like it's in parentheses, right? So then we know, that this, y is going to be equal to negative 3. And x is going to be equal to negative 1. So I'm going to go over 1 down 3, over 1 down 1, 2, 3. And then my slope is negative 1/2, so we're going to go down 1 over 2. down 1 over 2, down 1 over 2, down 1 over 2, oops, down 1 over 2, down 1 over 2. My solution is where they meet, and where they meet is where x equals 1, 2, 3, and where x equals 1, 2, 3, 4, 5, negative 5. Those are my two solutions. Remember that? Okay, now let's change it slightly. Let's make it a greater than sign. If I do a greater than sign, I have to consider the graph when it's above the red line. What's the V doing? Lucas, put it on my desk, please. What's the V doing? I didn't want to do that. What's happening with the graph, whatever's in blue, what's happening to it when it's greater than negative 5? Well, I like to look at it like it's on a number line. If that, see where what the red thing is, the red line? Pretend like that's your number line. Where, what are my 2 points I'm going to put here? The negative 5 and the positive 3. So is the graph going like this? Or is the graph going like this? Can you see clearly, guys, that the graph is doing, it's going in? Right? Is everything inside? So that means x is in between 3 and negative 5. Or you could say it like this. X is less than 3, and x is greater than negative 5, and put an and in there. Whichever one you want. But you have to have either like this, like being the x is being squished in there, or the and sign. But one or the other. Just this. What is going on? Right on me. Just this right here and this all by themselves is not correct. Okay? All right, let's do it with let's do this way. Let's make it greater than. I'm sorry, less than, and see what happens. So let's talk about the graph when it's less than the red line. Can you guys plainly see that the graph is doing this? You see that? It's almost like those arrows are going out. So if this was your number line right here, it would be x is greater than 3, x is less than negative 5, and it's going to be or, because it's going out, or. Does that help? All right, so now that should be enough for you guys to do yours. Can you do both sides for me, please? I'm going to walk around. Let me unpause this and let me do it algebraically for you really quick. It will save me time. Okay, so the first thing I'm going to do is I'm going to add 3 to both sides. This is algebraically now. And I get negative 1/2. The absolute value of x plus 1 is less than negative 2. And then I'm going to multiply both sides by negative 2. And I get absolute value of x plus 1 is less than, sorry, my sign switches. And I get positive 4. So now I'm ready, and I've got 2 different solutions. Right? I've got x plus 1 on this side and x plus 1 on this side. This one is greater than 4. This one is less than negative 4. Then we add 1 to both sides, and I get x is greater than 5. X is less than minus 1. That should be 3. Negative 5. There we go. Right? Isn't that the same thing that we got? Where'd the what? Where'd the 4 come from? I multiplied both sides by negative 2. Right, if I want to get rid of negative 1/2, I multiply by